How are we? Good? On a Saturday? This is Building Awesome Azure Function Apps, and I'm Rachel, and this is what we will look at today. Azure Functions. Anybody out there using Azure Functions yet? A few? Anybody even not heard of them yet? We at least heard of them? Well, you have now. So, at least from today. So Azure Functions, let's take a look at what they are and how we can quickly build a Azure Function app, put it in the cloud, and be up and running very quickly with some solutions to our business problems. So an Azure Function is basically like a regular old function, programming basics. Right, we start out with a class and one or more functions inside of it. Well, an Azure function is the same thing as your regular old function that you would program in any language. But we're going to take that and make it a little bit more, or else my talk would have to end right now because I just explained basic programming concepts that we already know. So we're going to take that little piece of code, that tiniest unit of code that we have, and we are going to supercharge it, put it in the cloud, and make it so it's easy to write, easy to maintain, and the best part, easy to not have to deal with any of that infrastructure nonsense. So I'll talk about that as we go through with the talk. So it's code, that code of a function. But a little bit more than just your basic concept of a programming function, you also have events and data as well. Now, in a regular programming model, sure, you're going to use maybe event-driven programming and you'll access data, but we're going to tweak these functions in a certain way so that we can use this event and data model to integrate systems, to be able to write custom programs and do all sorts of really cool cloud-enabled stuff. So we put those together, we get Azure Functions and a cool logo with a lightning bolt. Got to have that, right? Other than the Fox logo, it's like the coolest logo out there. So it's a unit of work, just like a regular old function. Of course, it executes, has a start and a finish, and has inputs and outputs. So you can thank me, Captain Obvious, for telling you these things. If we want to know where to get it, first, it's all open source. Microsoft, you may have noticed, we now love open source. More than open source loves open source. We're so open, things are just falling out. That's how bad it is. So open source and in the cloud. Functions derived from the WebJobs SDK. And WebJobs were a way to be able to run little bits of code kind of outside of the context of a web application, but they would also help your web application. So there's several repositories where you can get the source for functions, and it's all part of that WebJobs SDK. So you see the SDK, the scripts, the portal, the templates, etc. Some things that we would do with functions. Instead of just leaving it as one tiny unit of work, this tiny unit of work we might put together with other units of work to be able to produce these systems. And many of these systems that we have are going to alleviate those business problems that you have, or many of the function apps we put together will alleviate those problems. So there's things you would do, or every company does. You have timer-based programs. You have a program that runs every night. Maybe it does sales summaries, or runs every week for payroll, or every month, or whenever, on a timer. We also do things all the time. Every business takes one kind of file and transforms it into another. maybe CSV to blob storage or to SQL or one format of data to another. You might have to do a little bit more complex processing, like SaaS, or doing graphs, or working with Excel. Everybody's favorite, Excel. It just won't go away, right? Excel. We can also do things like image processing, stream processing. We need to do a lot of these things. And nowadays, everywhere you go on the web, you've probably interacted with a bot. If I go to my airline's website, a little pop-up wants to chat with me all the time. Well, that's not a real human generally. They make it look like it until you start talking to this bot. Then you realize, oh, that's not, humans don't talk like that. Still not quite there yet. So things like messaging and stuff like that, customer service, and integration. So we might have custom programs that we wrote, and we need to integrate those with third-party programs that we've purchased. So you might have something like a customer relationship management system, maybe our own Dynamics CRM, or one of the like Siebel or Sybase or one of those big systems, and you might need to integrate it with another third-party system or your own in-house custom systems. Well, to do those, all of these things, what we would normally do is, crank up Visual Studio, write ourselves a program, deploy it, and then listen to the administrator, your sysadmin, complain about, your security and all this bad stuff that you did. And then when you're done with that, then you could listen to the DBA complain about all the bad things that you just did. Deployment is a bit of a headache. Wouldn't it be nice if we could take all of that headache out of there and maybe not even have to talk to the IT admin? Yeah, I'm down for that. Just stay over there. So I could just put it in the cloud. So we could take these kind of things that every business does, and instead of making a big to-do about it, we can actually just make them small function apps, or even big ones, but it could be without the hassles of deployment and without the hassles of the platform. I find as a developer, it's very annoying to stop focusing on business problems because you have to deal with something on the server. It's 2017. We should not be having to deal with stuff like IIS anymore, right? So that's what we don't want to do. So in the real world, those things are all being done. Moving data back and forth, running things on a schedule, as well as some really cool stuff with functions. Lots of tracking. It's getting to be very, like Big Brother kind of watching you. Packages, tracking packages. Courier services in the US are using a lot of functions, Azure Function apps, to do package and vehicle tracking. So we'll see how that would work nicely with that. Your data cleanup, moving data around, batch processing. We have a customer that's doing like 30 million executions roughly every 12 hours in aggregating internet traffic. So many companies that you work for, they don't want you on Facebook. Imagine that. They would rather you work instead of playing around on Facebook, so they monitor your internet traffic. Well, that monitoring program, some of them now, are using Azure Functions to capture that and then let the boss know exactly how much time you are spending, or wasting rather, not working. You can make an API out of a function app, and people do, and there's very many capabilities for it, but functions shine in the data processing and in the microservice architecture space. So the cool thing is they don't have to be RESTful. If you do an API with it, you probably want that. But it's more about the back-end hardcore processing rather than just putting up a website that people interact with or an API. Again, you can do that. You can do an API. You can do CRUD operations. That'll work just fine. We'll see underneath the covers, it is just an app service web app at some point. So you could do that, but generally functions shine on the other side, where we're doing the data processing and the stuff where I want to write some code, push it out, and be done with it. And just have it running without me having to babysit the program. And then, of course, having the DBA yelling at the side and the IT pro yelling in that ear as well. So it's all part of the serverless computing paradigm. So with serverless computing, this is my favorite new buzzword, because there's a server there. It's a fib. It's not really serverless. It's just that the server's over there. It's somewhere else. It's just not here, which is good, because be over there. I don't want to deal with the server. If I wanted to do that, I would be an IT pro, and somebody else would be here making fun of me, instead of me making fun of the IT pros. All right, so serverless computing means we get to run code and not computers. IT pros run computers. We're programmers. We want to write code and run that instead. So what happens in a traditional program? We would start up a project in Visual Studio, maybe an MVC application or web forms, and you might even do this just to move data back and forth, or even to have a program that runs on a schedule. Or something else that you might do to run on a schedule instead of a web app would be a console app, a Windows service, or some other project type out of Visual Studio. But you would make a Visual Studio project and solution. You would write your code, and then again you have to go and deploy, and you have to run not just the code, but all of that stuff that goes with deploying. And nobody ever wants to deploy on a Friday, do they? That's the worst day ever, because then your whole weekend is just shot. It's just going to go downhill. So we don't want to do that. What happens, though, when we do things like this? Traditional programming methods kind of leads us into the monolithic way of doing things. So then we end up with these large programs that are harder to maintain. We know from principles, such as solid principles, that smaller code, things that are single responsibility, that's better and easier. Taking out small parts that you could deal with in isolation, fix them, write them, and then put them back, and hopefully it will not affect other parts of the system. So that's what we want to do, and we want to do it with a server that's over there somewhere. I don't care. I don't want to see it. I don't want to touch it. I don't want to know about it. I just want to stick my code out there and have it run. That's what I want. I'm also very lazy, so I'm totally into this. Right? Less is more. So serverless computing is generally considered PaaS, or platform as a service. Good things about it is it's usually stateless. Somebody will ruin that. They'll write bad code, but that makes it scalable. You can take complicated systems and break them down into easy, discrete parts. And they are often good for those scenarios that don't fit into the file, new project, monolithic app. So things like a sporadic workload, such as your conference that you're at right now. Up until, when did you register? Maybe a few weeks ago or a month or two ago. But for most of the year, the Eventbrite website did not care about this conference, right? Any event that is a yearly event, or when you have ticket sales. So it would be a sporadic workload, or something that's not regular. So serverless computing is great for that. Just think if I had to run an event every year and maintain all of the systems and IT stuff the whole rest of the year, right? Every Patch Tuesday, you got a patch, all that good stuff, not good, bad stuff actually. All of that stuff you have to do, even for the 10 months that you're not using the program. Well, that's just silly. I have other things to do, right, than deal with that. And then having the IT pro yelling at me for having to do that. So I make a lot of IT pros yell, in case you haven't noticed. So things like that. And also, instead of just forms over data, it's generally doing stuff, actions, and event-driven. So as part of our serverless computing paradigm, we have patterns. One of them is the sporadic stuff. Anything that's outside of your traditional structure, right? If it's real simple things, you might just have a simple program that moves data from database A to B. Who needs a whole big project for that? You might not. But what if you do have a giant project that's outside of the bounds or much more complicated than it should be for a regular Visual Studio project? Those things are perfect for Azure Functions as well. No human involvement. That's again why I'm a programmer. I don't like humans either. So I'm very grumpy. I don't like anything. Lots of services involved in integration, and that we have to do. Every manager that gets paid more than everybody here, way up in the food chain, wants all of the systems integrated, right? They want that big system to rule them all. That's never going to happen. But we do have multiple systems, and we do need to glue them together. And we do that by writing programs, deploying it, and then dealing with nonsense after we deploy it, and multiple ones. So if we alleviate those headaches, we could focus on business problems. We do not have to worry about infrastructure. Not no deployment, but the deployment is not an issue. 2 clicks and you're done. And we also get lightweight and cross-platform benefits from this. So our serverless architecture starts with the app service runtime. So this is where you'll see things like debugging and deployment slots and Azure stuff. The stuff that you really don't need to know about. Just know it's there at that bottom level. On top of that, the next 3 levels are the web jobs libraries and SDKs, then the script runtimes. On top of that, the language runtimes. And with Azure Functions, you get a whole bunch of choice. You get JavaScript, C#, F#, Python, and new languages all the time. So that's kind of cool. If we have various development skills and languages, we can incorporate multiple languages into an app. That's also going to help us integrate stuff. On top of that are just some APIs, like the programming model for web jobs, and what we will see, which is on the top right, the web jobs extensions. These things called triggers, inputs, and outputs. They're going to be the core of how we write the functions. So this is just that last slide broken out a little bit more. The blue and the purple here. We have triggers that will set off our function and function app into motion. And then we need to get data from somewhere, so we will have inputs. And we usually want to produce an output as well. A little different than a website, right? A website, some user interacts with it. Not necessarily with functions. You could set it up that way, but generally, we're going to push our code out there, and it's just going to run. This helps us alleviate another problem, again, the monolith problem. We end up writing these programs, and they end up getting to be a little too big sometimes, and then they look like that. Yes. So we don't want to deal with that. What I'd rather deal with is those. Yes. Yes, much better. If you had to go out in the yard, you would rather take the small shovel, right, to the ones on the right instead of the ones on the left. It is much easier just picking up after one little doggy than it is picking up after a horse, right? So that's what we want to do. Somebody's going to write code like that. I'd rather it be little poops of bad code than a big block of it, right? So Azure Functions will help us do that. So let's look at programming them. Again, the code, lightning bolts in our code makes Azure Functions. So there's multiple ways to write them. I'm going to show you the portal, but you can also use Visual Studio Code, or the Azure CLI, which is now called Functions Core Tools, are also ways we could help write these functions. So what I would do is log into the Azure portal, and I've already logged in, and I have a few function apps, and a function app would have one or more functions in it. If I want to make a new function app, I can click my plus sign, and then as soon as something pops up, there we go. I could start looking for function app. Come on, Azure. There we go. Click create. And then what it does is it gives me some options, just Azure options like the app name. And it has to be a unique name. So I will call it What a Cool App. Let's see if somebody else has What a Cool App. It's thinking. I could pick my subscription and other information such as the resource groups that I want, hosting plans and locations. I will say for your hosting plan, you probably want to go with consumption. Consumption will allow you to be charged only when your function is executing. Not just when it's up and running, only when it's actually executing. So you're going to get the best cost benefit there. The other plan is the app service plan or the classic plan, and that's kind of almost like some cell phone plans. You prepay for like a chunk of time. If you don't use it all, you may have wasted some money, but if you go over, you might get charged a little more than you like. All right, so probably want to go with consumption plan. Click create. Oh, it is. What a cool app. Somebody else actually thought of that name. Imagine that. All right. Come on. Oh, okay. Apparently it did take it. Okay, so it's starting to deploy that. What I'll do is hop over here to an app that I've already created. A raffle. So I have nothing, somebody else could have my badge if you want. I can raffle that off. Right. I'm also cheap, so I didn't buy anything to raffle. So here, I have a function app called Raffle It. So this gives out little raffle tickets, and then I can select winners for them. And inside of this function app, users can get a raffle ticket, and I can also select winners, and I have some other maintenance type of functions. So one or more functions are inside a function app. So if I look at the get raffle ticket function, and I click on that, Wi-Fi is going to be a tad slow. Here we go. You can see it's just plain old .NET code. In the case here, I'm using C#. Now this could be Python or one of the other languages. I'm just using C# for the demo. So I could come and write the code right in here. I can also write it in Visual Studio and push it up. It doesn't matter, whatever you want to do. Once I write the code in here, if I click on this View Files over to the right, I can then see the files as well as test them. So I could test it right in line here. I could take all this code and run it. Now with this code, I'll put the files back. If you take a look at it, the only slightly weird thing is the #rs at the top. So this would be a library that's available, but I wanted to do an add reference, kind of like a NuGet package or the old add new reference dialog. But this is the way to reference them in Azure. So we have some built-in ones, but if you upload your own DLL as well, you could reference it this way with a #R. Now inside of this function, that's going to do a raffle. I decided how I would set this up is that I would allow a user to go to an HTTP endpoint and request a raffle ticket. They get a little number, and then you have that number to see if you've won anything. So when they go to request the ticket, I need that endpoint, and I want to collect some data about that. And actually, in this case, I'm just making a random number. Then I want to store the fact that I handed out a ticket and that it did not win yet. And later on, I will mark off who won. Now, I could use any kind of data storage. I've decided to use an Azure storage table. It could be SQL, it could be anything. I'm just using Azure Storage because it is super easy in Azure Functions. So I could do those things by declaring them in the code. So the first thing that you'll notice is I do have this method, and it's called run. So we generally have a method called run. And you notice that it is just one method, right? One function in this function. I can put multiple ones inside of here, the get raffle ticket, but that's kind of frowned upon. That's not really how it's supposed to work. Now, for demonstration purposes, I did stick a little class in here to represent the Azure storage table. So a ticket number, the date and time, and if it was selected as a winner. So in here, I do say, hey, I want to use an HTTP request. Every function gets logging, so you will always see the second parameter called log, and it's a trace writer. And then where am I going to store these tickets? Well, I'm going to store them in an Azure storage table. So I just called it ticket, and it's of type iCollector ticket. Now, things we need to know is, well, why this iCollector, and where do you get this from? Right, all this stuff. Right, so what I could do to set up this function signature, and these things that are in the signature are called the input bindings. They're also output bindings as well. And I can set them up by clicking in that Integrate tab. Now in Visual Studio, this is just a JSON file, and we'll see that in a second. Now here's where I see those three core elements: triggers, inputs, and outputs. For now, you're allowed one and only one trigger, and the trigger is something that launches or starts this particular function. So in this case, the trigger is an HTTP request. It could be a timer. A timer is very popular. Or instead, I could have the trigger be perhaps when somebody puts an item on an Azure queue, or in a database, or blob storage, or any of the items in Azure. So I can have multiple things that are outside of the scope of this function that actually trigger the function to run. In this case, it's just HTTP, also a very popular one. I can select the HTTP methods if I want. I just left it as all for default. Right here, this name, let's zoom a little bit. Go down here. This name, this is that name in code. So whenever you see the name here in this Integrate tab, that's what you call it in code. So you could call it whatever you want, but what it is here is what you'll see back in the code there. And then some other options. Now each of these, the triggers, the inputs, and the outputs, if I click on this little documentation link way at the bottom, then you will see the settings and properties that you can use for this particular type. So in this case, the HTTP trigger and some sample code. Right? So we could copy and paste instead of having to go to Google and copy and paste. Right? Because it would be bad code if we just copied it out of Google. It's okay if we just copy it out of here instead. Right? For inputs and outputs, I can have one or more or zero or more inputs. In this case, my trigger is doubling as the input. But the same with outputs. I can have multiple outputs. I left the default in there, but I added an Azure storage table. So this function accepts the request and then writes out to a table. And if I look here again, I will see the name, and that's called tickets, lowercase t. The table name, the actual object in Azure storage, is tickets, capital T. And then, of course, I could set up my account where I want to store it and all of that stuff as well. And there's documentations for this too. So I get my triggers, inputs and outputs, and I set them all up in here. If I come back to my function code, you can see there's the HTTP request, and there's my lowercase t tickets that are of type uppercase t ticket, right? So it's looking at that actual Azure storage table. I made a reference to the Azure storage library and did myself a using, so we're good to go. All I need to do is write code. Now the code part is just .NET code. We all already code that, so I'm not going to go into details. But as you see, it's just adding a new object, much like you would with Entity Framework or something else, and just giving the properties, and then it automatically adds it to the storage table. Then what I'm doing is returning a random number. And here, this didn't want to show me anything last time when I did it. There we go. So if I refresh, I should get a new ticket number. And you can actually do this yourself. You can go to raffleweb.azurewebsites.net/ticket, and you should get a random number, a ticket number, to win a lot of nothing at the end of this talk, right? So I can do that. But there I get that. Now this is just an HTML page, HTML. And just so we can see it, what it looks like, I'm pretty sure you know what HTML looks like, but just in case. So here, just the button, right, to go, I don't even need that. It just generates a ticket for me. A little bit of Ajax that just goes. So if this were a spa app, it's a really bad spa app, but a lot of people do Ajax requests, so I just wanted to show doing it with an Ajax request. So really all I'm doing is just grabbing the data from the raffle_it function, and then off you go. So just doing a quick Ajax request from a single HTML page in this case. Now with my functions, oh finally what a cool app got deployed. Takes a few minutes. If I come in here, I could find it somewhere. And you see it starts off with just nothing, just an empty function app in which I could put one or more functions inside of it. When I go to create one of these functions, how I can set them up easily are with Azure Function templates. So if I click New Function, I get some of these kind of basic ways of working with it. Do I want a webhook, the timer, or data processing? Well, what I like to do is skip that and go right to this link right here that says create your own custom function. When I click that, I get extra cool stuff. Here I can pick out more languages. Oh, and I keep forgetting we just added TypeScript recently. So more languages. So I could see what templates are here for what language. So I had a HTTP trigger in C#. Instead, I could do a timer or service bus queue or a regular queue. So any of these things can launch the function. So if I picked service bus queue, whenever an item entered the service bus, it would launch the function. You can even have a manual trigger for that person who just likes to click it themselves. Really? Only a couple minutes? All right. So I would pick something like, say, a timer. You give it a name. And in here, they use a little cron expression from the land of Linux to say when the timer should happen. All right, and then it gives you a little bit of sample code. But I could come to my integrate tab, and here I will see there's my timer, called my timer, right? Matches up with what's in the code here. And of course, you get the log again. And then I could add inputs and outputs. So maybe on a timer, I would say, hey, whenever an Azure Document DB database is updated, I want this function to run. Or anything on it, when the timer triggers it, I'll check Azure Document DB, right? I could do stuff like that with this input. And then the same thing with an output. And here you see it's actually going to give you all of the options that you need. Now with all of these options, we get to point and click. Let me go to the raffle ticket and just do an integrate here. You can point and click, or you could click on this link in the top right corner, the advanced editor. So advanced. It's just JSON, not really advanced, not at all. So with this file, if you come back to the function and look at the view files, you'll see here it is again, function.json. So that describes the trigger, the input, and the output bindings. And you can have as many input and outputs as you want. And then you'll see the run.csx. So that's all the function is. Right? And you have multiple of these CSX. It could also be CS as well for C#. Or if it's Python, you might see a PY instead, or whatever the language is. But I take these, and I can just use them in Visual Studio if I want, and deploy them that way. So really nice. And then I could put multiple ones together, as you see here. The get a ticket, I have one to select the winners. Complex algorithm that just grabs every 25th item just randomly out of the table. That's all that does. But the same thing, I have a run.csx and a function.json. If I come to my integrate tab, then you will see here I have both an input, that's the storage table, and the output. So when somebody runs the trigger of selecting the winners, it looks at one table and then updates that same table. All right, so these are the inputs and outputs. Instead of just calling a function like you would in standard programming, you let this function just sit there, and it can kind of talk to the environment, right? It can talk to the Azure storage table or to whatever because of the trigger that starts it off. And you get a lot of really cool stuff in here. As part of, say, the outputs, some of the things that I really like, and I wrote the documents for these. SendGrid, the bot framework. Oh, that's where this comes from. That's what the airlines are doing. So you can have something that triggers a bot to annoy people. Or another favorite annoying people, SendGrid email, right? So I can maybe do a timer trigger and then mass email everybody until they are annoyed to death. I forgot to disable a function and annoyed myself for an entire week with this. So we got to watch that. Or notifications, or Twilio, SMS. So I can have some trigger that runs the function, and then I could text message somebody. And these are really, really easy services to work with. Also, external tables, such as SQL, MySQL, Microsoft Dynamics products, other third-party CRMs and things like that. So you get a whole list of these different systems. So you see this one little function can tie entire systems together by accepting an input from some SQL database and maybe an output to some Dynamics product or something like that. And you get to configure them all with the JSON bindings. Now in Visual Studio, really quickly, if you do a file new project in 2017, you'll see Azure Functions. You do need to download the Azure Functions tools for Visual Studio. It's a separate download. Once you do your file new project, you'll see barely nothing in there. It just has 2 JSON files for Visual Studio. And then I can do my file add function. When Visual Studio isn't not responding, there we go. You know, Visual Studio. So I can, oh, I don't even want a file. I want to add a new item, Azure function. And in here you'll see it just goes straight to .cs. It doesn't even put the X on, but it doesn't matter. So I could do the same thing like a timer or HTTP, whatever I want. And I could pick that out, click create, and then you'll see it makes the same .cs file. The only difference in here is they make nice little attributes in the updated version of this, where you could actually see a little more information inside of your signature. Then all I need to do is take this, and I could do a right mouse click and a publish when I'm ready, and pick a new, like make a whole new function app or add it to an existing function app. And then again, I can have these multiple functions that go through and tie systems together, or just do cleanup or whatever it needs to do when it needs to do it. So we get a lot of benefit, and notice what I don't have to do. Once, if I'm working in the portal, nothing. In Visual Studio, I just click publish and it just asks me to log in and then pushes it to Azure. I don't have to deal with the DBA stuff. I don't have to deal with the server stuff. I just write my code, run the code, and knock computers. And it's the smaller bits of code. So I can write little pieces of crappy code, right? The little poops, and deploy those. And only have to deal with those instead of the big monolith that a lot of these kind of programs end up being. So this should help us write a little bit better code because they're smaller units all working together. And of course, if you use Visual Studio, you can then add your favorite unit testing suite in here as well. And when you go to publish, or after you publish, you can actually go to the platform features, to deployment options, and tell it you want to integrate with GitHub or TFS or wherever you want to deploy. OneDrive, that's so cute. Yeah, don't publish there. Don't publish. Why is that in there? You guys. That's my team. I love them to death, but why is that in there? Here's GitHub. And then you just pick out your repo, and that's it. So it's all just pointing and clicking. You set it up once, and then you have continuous integration set up for, from Visual Studio. Anytime you push, it will just update GitHub, update your function as well. So again, all of that back-end IT pro stuff, not for me. I don't have to deal with it. And now it's not for you either. You don't have to deal with it. I find this really great for ASP.NET developers. You could take that code and start breaking it down into manageable chunks to get stuff done. You can get rid of the console app that runs on AT commands, right? Because you could use a timer here. And you could get rid of all those weird little programming things you got to do when you deploy a service. You can just push it here in the cloud. So that's what makes it really good. And I'm pretty sure I've gone over time. Really the only other things about functions is just keep in mind that when you do it, there's always the chance for people to write bad code. If you write bad code, maybe you have a lot of thread.sleep in there. Don't do that. That's not good. That'll chew up your execution time, and that'll cost you money. So one indicator of how crappy the code is how much you're paying for it. I found most of our clients have actually had a reduction in cost of significant amounts, just because they're writing better code, smaller chunks of code that are just executing in tiny amounts. Even if it's 30 million executions a day, there are 30 million tiny ones, one right after another. Also, scaling's automatic and all that other good stuff. You don't have to deal with it. It's perfect for lazy people like me. I love this stuff. So that should get you started, and you should be able to start writing Azure Functions and getting some really cool stuff deployed to the cloud, and finally tie those systems together without, too much pomp and circumstance. So thanks for listening. Thanks for coming to NetConf.